mine is about 50 or 80 years ago. These two guys were coming in and taking out these 100 to 200 grams per ton pillars. Pillars are support pillars that were left in place to keep the mine stable, right? So you can't take out those pillars because you destabilize the mine. So at that time, they couldn't resist this grade, and they started, scratching away this pillar, getting out material, and they caused the mine to collapse. And in collapsing, and when I say the mine, I'm talking about this artisanal, small, maybe 60, 70 meters in the maximum depth. It's not 60, 70 by huge. No, it's they come down in like a shaft, and they go these, small, narrow vein mining. So the point I want to get to is that in having the mine collapse and being trapped, these miners couldn't get out and they passed away, right? So the government came in and they stopped the mine. No more mining allowed. They got an excavator. They managed to open up a part of the tunnel and get these guys, get the bodies out for the families, and they shut the mine. And that was good news for us because, and to give you an idea, the son of the miners of the past today is 82 years old. It would be 82. He passed away last year, just to give an understanding of how long ago we're talking about. So fast forwarding to a few years back, 4 or 5, when Yamana was interested, there was a new owner. And this new owner was called Juan Flores. And he had this vision, this plan, that this high-grade area where it had collapsed, he was going to go away from this area to where there's a valley, go down the valley to be below this, this collapsed area, and come in along the vein to reach underneath this high-grade material. And obviously, the closer you're coming, the higher value of the mineral. So we did, like Mr. Wee said, he put the seed capital up. We did the sampling, mapping, and the interpretation of Kayla 2. And in doing that, we discovered 4 veins on the surface. And within those veins, a very high-grade material, 58 grams per ton, 49, 16, and some other veins, they were more narrow, and then some other veins were up to 4 to 6 meters wide, which is something we weren't expecting in width, and they were running at about 6 grams per ton, so big volume and high grade. If you imagine 99% of the gold in the world that's mined is under 2 grams per ton, right? Because it's bulk mining, it's open pit, it's large volume, and that's what is being produced today in the volume. Because high grade is not easy to find, right? It's hard to find. In this business, grade is king. So the higher the grade, the lower your ounce cost. Today, most of the gold's ounce, if you look, not all, there's some mines that are the exception, averaging over 1,100 up to 1,200 an ounce in some cases. The cost per ounce, the all-in cost, not just the operating cost, the all-in cost to extract that ounce of gold. So in our business, our success is based on what's in the ground, right? So our job is to identify these deposits. The geologists need to be like detectives in understanding what happened in the past, right? How were these mineral formed? What was the temperature? Based on that temperature, the type of mineralization, what depth extension would be possible with this type of mineralization based on other mines in Chile and around the world that have this type of temperature and formation. And these are the things, the tools that geologists use from their experience, from their studies, and from other mines into understanding how the deposit was formed and how it's kind of getting the key to the secrets to predict and know where the mineralization is or where it's going or where the parallels are. So after we did many months of sampling, mapping, topography, etc., we started to get a picture of the 4 veins on surface, their angle they're heading in Kayla 2, and just taking those 4 veins with a 400 meter stride, so that's length. The claim has a kilometer, but we're just talking about 400 meters length with a 200 meter depth. Remember, I mentioned it would go to, should go to around 300 to 400 meters. We haven't proven that, we haven't drilled deep, but that's how these type of deposits usually are. But taking the 400 by the 200, and this is a memo that the geologist did that you can all see, that's how we got the number of 351,000 ounces in Kayla 2. So what Mr. Wee was referring to is we have another claim, the same size, called Kayla 1. And in Kayla 1, there is one vein that was known, meaning you could visit it, you could see it. There's some small artisan, workings, old-timers working there. And that grade was 75 grams per ton. In that location, it's not a parallel vein because it's too far away. In fact, it's a parallel system, right? So this week we put the excavator to work over there. We've been focusing on Kayla 2, but this week we put the excavator there to do trenching and to see this vein, how long does it go? Are there any other veins with it? And then mapping and sampling it, learning what is its grade and what is its average grade going along this strike. So today we have now 2 veins in Kayla 1. We haven't got the resource yet. The geologists are not ready. They need to wait for the assays to come back from the laboratory, and then combining that with the sampling and the mapping, they can determine a potential resource also in Kayla 1, right? So based on the Kayla 2, 351,000 ounces, we made a mine plan around 38,000 ounces. So about 10% of the potential. We used that number and based on the veins, based on the average grade that we know, because we know the grade on the surface and we know the grade in the tunnel that was made by this Juan Flores that I mentioned before. And this will all make more sense when you see the video and you see the information. But I'm just trying to paint a little bit of a picture before you watch that video. So basically, our goal is very simple. We want to go underground, following the vein, the same vein that is in the high grade area. We want to follow that vein to that area of richness. And we want to continue beyond it because we know there's mineralization beyond that location. We have an outcropping of one of those veins about 900 meters to the north of this high grade area. And we are about 300 meters to the south in the tunnel. So it's a very promising deposit if you consider we only counted 400 meters for the resource, right? So what do we need to do? How do we de-risk it, right? That's what all this comes down to. In this business, there's facts and there's tools and there's ways that you de-risk your deposit, you de-risk your project. And all of those tools cost money, right? So the first tool is sampling, mapping, and understanding the veins from a surface perspective, right? And you use tools like excavators, geologists, topographers, and those teams of people are what makes that information talk to you about what you have, right? The other way is you get a drilling machine and you use a HQ head, which is about that wide. It's a diamond core drilling rig. And, imagine a straw of, a drink, orange juice or whatever. If you put your straw in the orange juice and you hold the top and you lift it up, you have a core sample of the orange juice, right? And you really, this diamond core rig takes a core sample of the rock. So it drills in meter by meter, and that meter comes out. The geologists do the lithology, like the description of what they're seeing, this quartz, pyrite, iron oxide, sterile, whatever it is, meter by meter. Oh, we cut the vein. We cut the vein at 20 meters, and it went from 20 meters to 21 meters, and it has, yellow quartz, iron oxide, which tells us, the geologists, what type of grade it could have, or what type of mineral is there, because you can see iron, you can see the quartz, you can see the different minerals that are inside of that vein. So the purpose of that drilling is to know ahead of your production. So remember how I mentioned there's the tunnel, right? And there's the vein, and we're coming along this vein, eating the mineral, extracting the mineral by split blasting. So split blasting means two blasts, one for waste rock and the other for the vein, right? The two, which is what we want. It's like the filet meat. We want that. We don't want it mixed with the sterile material, right? So we drill holes, we put in explosives, we detonate, and then we allow the gases to settle, and they come in and they muck out the sterile material, and then we do the same to the vein, blast it, and we muck that out and put it onto the ROM pad, or the stockpile pad, and we repeat and repeat, and in doing that we advance along the vein. So the vein, the vein is like that, right? It has a slight angle, but it's a solid hard rock. So it has depth, right? And it has strike, right? So we come in at one level, but then you have the possibility of creating other levels and blasting the mineral in between and increasing, ramping up your extraction, right? As well as you can open parallel veins. So remember how I mentioned before, you do a cross section, and you come across and you cut vein 1, vein 2, vein 3, vein 4, and there you open two directions, north, south, in each one, and pretty quickly you go from doing 300 tons, which is what we're doing this month, to doing 2,000 tons in a year, right? Because you've been able to open up these new veins. So all of our, if you do a building, you have to build the foundation and all the floors, right? In mining, our limitation is our velocity to develop underground access to liberate the gold at a higher and higher velocity. And that's why they call it ramping up. And our tool for de-risking that vein is by using all of the geology that we mentioned before, right? Surface, topography, mapping, interpretation. Then you put the drill rig underground. So remember how we said this is the vein, right? So if this is the vein, we want to know what it's worth. So the drilling rig comes and puts a core, puts a drill hole in different positions of this vein ahead of your production, right? So you know what you're going to be earning, what you're going to be extracting before you get to it. And that's why you drill. So a public company or an international company or a company that runs under a certain standard does that practice. So your Barricks, your Anglos, all of the major mining companies do exactly that. Mapping, sampling, interpretation, drilling, production, right? So just they do it with a different budget, with bigger equipment, maybe bigger deposits, but it's the exact same principle. There's no different to what we do and what they do. And that's how you de-risk it. Now, the reason why I have an opportunity in South America is because the distance between the small artisanal miner and the major mining company, the distance of their budget, right? So this small guy, he doesn't have the, $400,000 that we're going to spend over the next 60 days just in drilling to de-risk our next, year or two of production, he doesn't have that available. So what does he do? He just wings it, he just goes for it. He just goes along the vein and let's see what happens. So in the process, he doesn't know if he gets a pinching, or if this section doesn't pay, or you should bypass to the parallel in this part, or here's richer, focus here. He doesn't have any compass, any map, right? He just is following his nose. Doesn't mean that he's wrong. It just means he's taking more risk than he should, right? Because if it doesn't pan out, what's he going to do? He doesn't have the facts to make a adjustment, right? So everyone on my team has done this before. This project is much smaller than what we've worked on in the past. Why are we excited about a smaller project? Well, we're excited about the potential. We're excited about coming in at the earliest possible stage of a deposit where it has 0 ounces, to then it has a potential of 350,000, to now it could be as high as 700,000 if we're able to have a similar parallel structure in Kayla 1. It may not be 350, it may be 150, it may be 500. I don't know yet until the earth is exposed and the facts arrive, right? So right now we have been in production since the end of last month. We are extracting gold, or ore, we call it, mineral ore. We're extracting gold-rich mineral every day. Our first cash flow is going to be at the end of this month. We have a plan the plan is to extract 300, we're on target for that, 300 tons of mineral. And then we can take that mineral, as we're in Chile, which Chile is a big mining country, so there's government processing plants that will buy your material. You can process in external plants for a fee, and you keep your material, and then you can sell it to the government, a finished product, which is published monthly on the internet. Their price is set at the average price of the month before. That I'm referring to the government, right? But if you liberate your own material, you can sell to the government, which may be more convenient at times, or you can take that product and commercialize it another way. So you can have a physical gold doré bar and export that to Europe or to the US, or even sell in the local investor market, right? So there's a number of options in the gold business. One of the reasons why I personally started leaving the opal business and going to gold was it was frustrating for me as a young man that you couldn't sell the opals. You sometimes you would sell $100,000 worth, other times nothing, and the gold business you don't need to be handsome, you don't need to be a good sales guy, you just need to have the gold, right? It sells itself. It's better than cash, right? All around the world. There isn't a place in the world where gold is not valued or the people don't know what they have, right? So that's the why. That's how I got into this, and that's a little bit of talking about Kayla. So what I might do now is switch us to one of the short video presentations. We've got 2 videos. One is, a few months back, and the other is about a month back, and it'll give you a little bit of a picture of what we've been doing this last 5 months. Now, any questions? Sorry, before switching to the video. Okay, let me pull it up here.
Leon, you sometimes mention grams per ton, and then you change to ounce per ton. So basically, the conversion is like 28.1 ounce is 28.3 or 28.5 grams, right? Something like that. So when you are talking initially about the discovery, you're saying that 99% of gold mines are only discovering less than 2 grams per ton. Is that 2 grams or 2 ounce?
So just to be clear, when you talk about a deposit and you talk about its resources or its potential resources, you always refer to it in ounces, right? So always we're referring to the total ounces potential in a deposit. When we talk about the vein production, I always use grams per ton, right? So when it's the vein production, we use grams per ton.
Okay.
When it's a deposit value, we use the total amount of potential ounces, right? So coming back to the production, to the veins, most of the gold mine in the world, not all of it, but most of it, 90+%, is deposits that are less than 2 grams per ton. Why? For them to be profitable at 2 grams per ton, they need to have huge volume. We're talking a $4 billion to $10 billion investment. We're talking about huge amounts of equipment, 7 years to permit, try to get your water license, social approval, community approval. It's the elephant model that the world has been using to extract. And those deposits are also the ones that the world rejects, right? They're the big open pit craters that everyone sees and the massive tailings dams that could engulf a city, and that's the typical big business mining model, right? The other model is underground tunnels where you just mine the gold, right? You just mine the vein, and it's a higher grade material, it's a lower cost, it's a low footprint, it's a low impact, your tails are smaller, you can even drive past this mine and it'll do $5 million a year and you wouldn't notice because it's all tunnels, it's all just the grade. We're looking for the high grade material, right? Does that make sense, David?
Yeah.
Okay.
Thank you.
You're welcome. Oh, and anyone can calculate it. It's 31.1, right? So 31.1 grams to 1 troy ounce, right? It's not like the other ounce is 28. So 1 troy ounce is 31.1 grams. So if anyone wants to calculate the, from one to the other. Okay, so I'm gonna put here the first video. Let me just figure this out for a second.